Pointer in C. Yes, I said pointer. I know that this is some kind of difficult for, let's say, almost everyone. Pointer is one of the things people have difficulty to learn. And yesterday, I received that what I'm showing on the screen. What I got from a young student in Morocco. That student, she have a headache trying to understand how to make these exercises. She need that for the school, and pointer is pretty hard. So she asked me to do a video to explain how it works, and I'm sharing that with you today. That presentation is for beginner, but beginner, really serious beginner who's gonna really want to code with pointer, and maybe they are at school and they want to do some exercises. So let's start with exercises number 1. There is 2 exercises. The first one, it's an exercises where I need to create some pointer in memory and display the pointer and things like that. So I include my usual header, standard input output, and standard library. I'm going to create a structure, and that structure I'm going to call couple S. It's a couple of numbers. I have 2 numbers. That's all this means. It's a simple structure, a couple of integer. And I'm going to define a new type. A type, for those who are not familiar, it's like int. It's a type. When I put a variable name, that variable is of that type. It's related to this type. So if X is gonna reserve a space in memory to held integer. But when I'm gonna define a structure couple T, so a type of couple of integer, that type is gonna handle 2 integer instead of 1 integer. It's a new type. So this is my structure. I need to structure a container. You can see that as a container, and that container will be able to receive 2 integer value. One will be represented by X and one will be represented by Y. I need to have a function allow couple. The program is written in French. I'm translating that to you, but for C programming, there is no language preference. So I'm going to return a pointer. The star you can see here, means that I'm going my function allow couple, sorry, is going to return a type couple T, and we remember couple T, that type, it's a structure of 2 integer. This is what we're going to return in this function. And when we will call this function, we will give it 2 parameters, 2 integer number. That function will need a new pointer variable called 2 numbers. And the type of this pointer, it's a structure. The structure we just created, 2 integer. For that, a pointer point anywhere. There is no, it's just a memory address, in fact. You can see a pointer as a variable, but that variable contains an address in memory. Where it point, actually, we did not define anything, so it point somewhere that random space. We don't know exactly. But when I call malloc, malloc mean memory allocation. I request the operating system to give me a memory allocation. And what is the amount of memory do I need for that? It's the size of couple t. Couple t, we remember it's our structure with two integers. It's going to evaluate the size of this, and the size will be two integer. The operating system is going to search in the memory, and it will say, I allow you to use, I reserve that space in memory for you. It's going to return the address in memory for us. And two numbers will be now assigned to that memory location. At that memory location, the x value will be x. So you remember the x here, it's the x here. We're going to put that in the memory space we just received from malloc in the container x, and we put the y to the same space, but the y variable, because that memory space have two integer reserved for us. We can assign value into it, and then we return the address we receive from malloc. That this function, we give them two number, reserve a space in memory, we put the number over there, and we send back the memory address to the requester of that function. I hope you understand this very well. Let's continue. I did another function. The other function is display couple. I just want to show the couple on the screen. Let me translate that for you. It's going to be easier, maybe. I will call it show couple. Show couple, it's a function. We give him a couple. Is going to print the numbers. The numbers are, or the number in that couple are, and then we're going to print couple x and couple y. We're going to receive the memory address that we reserved. We're going to go to that memory address, and we're going to use the x value to print it first, %d, and the second %d will be the second value over here. You can notice that here I'm doing, when I use variable in my structure, I use a dot. Here I use dash greater than sign, because here it's the way to talk with the structure when that structure it's a pointer, and here it's not a pointer, it's a normal variable. The difference it's when I'm gonna talk about the difference later. Let's continue first. This is my function to display couple. Okay, that one to allow couple, and that one to show couple information. Another one, free couple. Free couple mean when I give you the address in memory of a couple, free that memory location. I will no longer use that memory location, and I don't want that memory location to be reserved for nothing that I'm going to use. You can free that memory, and now we're going to have two more integer free in our 4 gigs machine. It's not a big deal, but it's a good way of programming. You reserve memory when you need it, and you free that memory when you no longer need it. We're gonna call that function only when we don't need that memory to be reserved for nothing. This is the main function. The main function, we said, okay, we have a new type, a couple type. It's a pointer, and I'm gonna call that my couple one my couple 2, my couple 3, 4, and so on. I will say my couple 1, and I'm calling the function allow couple. Allow couple, I give him 2 number. So the first number is going to reserve a space in memory that can handle 2 integer. And I'm going to put 4 and 9 at that memory location. And because I returned the memory address, my couple 1 will receive that address and is now pointing on that memory location. I'm going to call this again, but now with 2 different numbers. That function will reserve another segment of memory, and it's gonna return the address of that new segment in memory. I will preserve that address in my couple 2. Same thing for 3 and 4. Now I reserve 4 blocks of memory. Each block of memory have its own address, and I have 4 variables to remember those 4 address. Another function that I did, show couple. Show couple, it's my function to display what is the number that has been put in those memory location. Memory location referred here by my couple. My couple 1, 2, 3, and 4. I'm gonna show that on the screen. And at the end, I'm gonna free up this memory location because I no longer need, I just want to remember those numbers to be able to display the numbers, and then I'm gonna free them up because it's the end of my program and I no longer need it. Let's try that program. Exercise 1. I reserve my 4 memory segment. I put numbers in each, and then I display, and then the memory has been freed. And that's all. That's all for that first exercises. The only thing I want to come back for you, it's what I told you, the difference between a pointer and a variable when you go in a function. A good example here. I pass the value as the address, and here I pass the value as a pointer. This argument is being passed by value, and that pointer argument, it's an argument passed by address. The difference is when I receive the address as an argument, that means I'm playing with the real address location. If I modify something here, the real content of that memory or that variable or whatever it is going to have the new value of that function. When I use like this, I pass an argument by value. When I pass an argument by value, it means I did not use the real memory. I put that value on a stack, and I'm playing with the stack here. If I modify the variable, let's example, I said c equal 3. At the end of this function, the stack is destruct, and the original value has never been updated. So it doesn't matter what you do in a function like that. You can modify C anytime, and you modify C only on the stack. And because at the end of the function, the stack is no longer available, the original copy in memory has never been changed. You never change the copy, the original in memory. You change only what's on the stack, and the stack is a temporary memory space to do something, but at the end of a function, it goes away. Let's get with exercise number 2 now. I start with the same code as exercises number 1 because now that we have 4 segments of memory, what we want to do is a list. We call that a chain list. You remember I need 4 variables to remember 4 memory address. But now I'm going to have one list, a pointer pointing to the first one, and the first one will know where is the second one, and the second one will know the address of the third one, and the third one the fourth one, and the fourth one will said, okay, I'm the last one, there is no other after me. So couple S, couple T, you remember this, it's a couple of integer. It only means that it's a structure of 2 integer. Now I create a list S. That list, it's a structure that will contain a couple and the address of the next couple. Every time I have a list, a small list, it means I have a couple and I have the address of the next one. The next one is going to have a couple and the address of the next one. And the next one is going to have a couple and the address of the next one. And the last one is going to have a couple. And the next one will be equal to null. Null just means don't look for another one. I'm the last one. This is the list we're going to work with it. Allow couple. You remember this is our show couple function. Nothing has changed. The same function. Display or show couple. Nothing has changed here. It's the same function as I told earlier. So I won't talk about that more than this. So my couple values are, and then I'm going to show the value. Show list. Show list will do show couple for everyone in the list. So you remember show couple is going to print X and Y. Show list is going to show X and Y of the first, X and Y of the second, and for the whole list. For that, what I need a pointer. I need, first of all, the big list, the main list, let's say that. And I'm defining a new pointer because the first pointer to my list, I don't want to change this pointer. I don't want to change it because I'm going to lose where is the start of my list. I never want to lose the start of my list. For that, I'm going to use another pointer. And that one, I'm going to use it to go through the list. I will go through to element number 2, element number 3, 4, and so on. So to initialize that, I start at the same pointer pointed by the beginning of the list. I showed that couple. And then I said, okay, now my pointer is equal to the address of the next one. And because the next one exists, it's not null, I'm going to print the next pointer, the number 2. And then I'm going to say, okay, now my pointer is equal to the next one of 2, so the third one. The third one exists. Now couple shows the third one and is pointing now to the fourth one. The next one of the third is the fourth one. The fourth one exists, that address exists. I'm going to show on the screen the value of the fourth one. And the next of the fourth one does not exist because there is only 4 in memory. And you remember when there is only 4, we say next is null. Well, we're going to see that later. But now my pointer is null. I end the loop and I displayed all the element in that list until I reach the null next pointer. Concatenate. Concatenate, when I want to merge something in my list. I have 2 elements, I want to add a third one. I'm going to concatenate the 2 element with the third one. And I want to add a fourth one. I'm going to concatenate with the fourth one. This is how I did it. I start with 1, I concatenate a second, a third, and a fourth. We're going to saw that. To concatenate, I'm going to give him the list, the list I have actually, and the couple I want to concatenate with it. And by the way, I want to concatenate now. When I concatenate, I want that one to be the first one and the rest of the list to follow the first one. Let's imagine that I have 1. I want to concatenate the second one. The second one will be the first one, and the rest is going to be the second. If I want to concatenate a third one, the third one will be the first one, and the rest of the list will be second and third, first and second, because it's the third, but the third is the first. I hope you understand. But every time we concatenate is going to be the first one, and the rest of the list is going to be after that. Concatenate equal malloc, again, because we want to concatenate something and give him, in fact, I want to create a new small list. I have a big list, L, it's my big list. And couple, I need just to convert it as a small list to concatenate with the big list. For that, I need to allow a space in memory. And by the way, if you forget to allocate space, it could work because you're gonna write in a memory randomly, you don't know where. Maybe you are allowed, so this is why sometimes it works, and you think you're a good programmer, but that's not the fact. It just worked by mistake. And sometimes you're gonna have a segmentation fault, core dump. Sometimes you're gonna see that because you forget something, and unfortunately you point somewhere where you are not allowed to, because remember, in memory, the memory is there for all program running on the system. In the system, there is many programs running at the same time. Just to give you an example, the PS process is showing me a lot of program running right now. Example, do I have something interesting here? Let's see. Type more. There is a bunch of things going on right here. But anyway, let's imagine I start Firefox. Just a quick learning. I'm gonna teach you more things than the pointer, just for you to understand. Now you can see in memory I have Firefox running. For sure, my program is going to use some memory, and Firefox is using memory too. And maybe my program, I'm programming a spying program that's going to scan all the memory, and especially the memory in Firefox, because I want to spy Firefox if Firefox load up some password, because sometimes when we go on a website, we put login and password, and Firefox asks, do you want me to remember this password? And maybe I need to scan the memory to search for that. So for that reason, every program have a segment of memory that it is allowed to work with. If you're not allowed and you do not allocate your pointer properly, you may receive, you have a segmentation fault, and bam, your program is killed and you're getting out of memory because of that fault. This is just what I want to explain you. Take care with these pointer malloc function. Don't forget to allow memory, to allocate memory. That was my concatenate function. Because I skip a little bit, I'm gonna refresh you. Concatenate, I always concatenate at the beginning, and I put the rest of the list right after. To do that, I create a small list, a really small, it contain only one couple. That couple is the couple I just received in parameters. And I'm gonna put next, and the next is going to be my list. Because you remember, that one will be the first one, and the next will be the rest of the list. And I return the new address of that starting pointer, because now I'm not going to start at the previous location because I insert something just before. My list now, my big list, should start at that address, the new location I just added. That function is to calculate different. I need a function to go through each couple in my list, and for each couple I want you to check if X and Y are different. If X and Y are different, I just want to say, okay, there is one couple, they are different. If X and Y are equal, no, I don't want to calculate this one. The other one is equal, I'll say, okay, I found a second one different, and so on. I just want to calculate how many of them is different. To do that, I'm going to use an accumulator, a variable. I call it accumulator, equals 0 because I'm starting. I create a new pointer, because you remember I always need my main list remember the original pointer, and PT is going to be a local variable just to go through the list. I'm going to use that pointer. So I start with the first one, and I said, okay, that PT, the couple inside it, the X value, is it different of that same PT, same couple, but Y value? Is it different? If it's different, okay, great, my accumulator plus plus. If it's not different, I'm not going to accumulate it. This is the way to count how many of them are different. Just for your information, we call that a post incrementation because plus plus is right after, but I can also write plus plus accumulator. We call that pre-incrementation. In the actual code, it doesn't make big difference. But for those of you who are really picky about those little things, remember that when you look into the assembler code for a microprocessor, you can see, let's say there is 2 gigahertz machine, the CPU. It means that there is 2 billion clock cycle per second. The processor is doing that, 2 billion clock cycle per second. When you look at the instruction, every instruction needs time to do it. But when you do a post incrementation, It usually take longer, some cycle, than a pre-incrementation. So the pre-incrementation is make you doing your program more performant, but only billions of seconds. It's not a big deal, but just to teach you that. And then when we see all the difference in our list, I position my pointer to the next one. So here I check only the first element in my list. I position my pointer to the next one. Is it no? No. Okay, I continue. I check the second one, and so on until I reach the end of the list. It doesn't matter how many in the list, as long as there is something to check. There is couple I'm gonna check. I'm gonna go through the list. At the end, I return my accumulator. This is a function that is gonna calculate how many of them are different. D double, we can see double up. Double up is going to look each couple in my list. When I found a couple, I duplicate this couple. Duplicate, I think it's a better translation. Duplicate. Every time I see a couple in my list, I duplicate the couple and I reverse the value. I put x equal y and y equal x. This is what the function is going. I'm going to go through the list. I saw a couple. I duplicate it, inverse x and y. I go to the next one, duplicate it, inverse x and y. Go to the third one, duplicate. Same thing for the fourth one. This is what I want to do in my exercises. Same thing, I start with my pointer, mini list, malloc. I allocate memory for that list. Because I want to duplicate, I'm going to create a small list, prepare my new couple in it. My new couple, I'm going to use allow couple. Allow couple. I will give x the y value and y the x value to reverse, like I told you, the value of both. At the end, I'm going to say, okay, now the next one is the next of my pointer. Because I have one, the pointer point under that one. I duplicate it. When I duplicate the duplicate, I'm going to say, okay, you the duplicate one. The next one is what was the next one for the previous one. I hope it's clear. If it's not, just rewind that videos and listen again. You should got it. I know it's hard. The pointer, it's hard to understand. You may have to review the video a couple of times, scratch your head a little bit. It's not easy, and don't be afraid. If you find this is hard, the pointer, don't give up. That's normal. Everybody. It's hard for everybody. You're not the only one. Okay. And the next one now you remember the previous one. The next one of that previous one is myself, the duplicate. Just to recapitulate, okay? I create a new list element for the duplication. The duplicate this the couple, a new couple is created, and a reverse x and y. I'm in a new memory location right now, outside of the list. A brand new memory, the operating system said, okay, you're going to use that memory, is available for you. I reserve it for you. Here is the address. You remember the address. You put those number, reverse. And it's okay, now, me, the new guy, alone. My next one is going to be the next one of my previous one. Because my previous one, remember where is the second one. I have to remember where is the second one now. And that first one, the next, will no longer point to the second one. It's going to point on me now. And me, I'm going to point on the second one. This is the way to insert my new list in the big chain, in the big list, okay? I hope it's clear for you. And I increment the number of insert I did. I forget to told you I reserve a variable here, number of inserts. And then, okay, I duplicate one more and one more. At the end, if I have 4 elements in my list, I should duplicate 4, not 3. So that's going to help us at the end to see if our program is working fine. And we do that until we reach the end of the list every time. And that's all. Here is the main program. I will change this by my couple. Look at the one. This part is the same as you saw on exercise 1. We just have 4 variables. We allow couple in memory. We allow couple with numbers, and one of them I change it with 2 equal number because I want to test my different function. When I do that, I'm gonna display just to make sure I did it properly. I'm gonna put some dash on the screen just to when I'm gonna execute it, just to remember before the dash was my exercises number 1, and it's still working. All my functions are working fine. It's good. After that, now I'm gonna play with the list and see if the rest of my display work fine. I start a new big list. I call it grand list, mean big list. I allocate a memory for this particular list. So I allocate my first one. And I said, okay, your couple will be the couple number 1. My couple number 1 is the first one, and there is no more. This is the last one because there is only one. I'm just adding one, and I'm gonna print the list just to make sure it's working. It worked fine, and it's supposed to show me only one, just to make sure. If it's working fine, I'm gonna add a second one now. I'm gonna add my couple 2 in grand list, big list, and I will call again show list. I just want to make sure show list now is going to show me 2 elements because I had 1 and I had the second one. I should display 2 elements. Now I'm adding 3 and 4. I had 1, it worked fine. I had 2, it worked fine. Now I'm going to add 3 and 4 before I'm going to show, and now I should have 4. And here, how many of them are different? How many diff? And I don't remember if I rename it. But when I'm going to compile, I'm going to see if I rename something and I forget something. And here I call it duplicate. How many of them are duplicate? Or I duplicate how many of them? Because I had 4, I expect to duplicate 4. And because I duplicate 4, when I'm going to show the list, now I'm expecting to receive 8 elements, and some of them are the reverse of the previous one. You remember that? This is how we tell it and we expect to get it. Let's compile that. I know I missed something, but I don't remember, and the compiler is going to tell me. Okay, this one. Should be couple, and calculate diff. This is the way I call it. Calculate diff. Now I fixed all the little renaming I forget. Let's execute the second exercises. And now we can see the first fourth was related to my exercises number 1. You remember I put dash just under to remember that the fourth one will gonna be like my exercises number 1, and it's still working good. Okay, now you remember I had only one in the big list first. I said, okay, I'm gonna start with one only, and the first one has been had. That's perfect. Then I had the second one, and you remember when I tell you the function, I said when I'm gonna add one is going to be the first one now, and the rest of the list is gonna be after that. And this is what happened. I had a second one. He take the first position, and the list going after. Here I insert third and fourth one, and every time they took the head of the list, and the rest has been attached at the end of the list. So it's working fine. And how many are different? The count is good. So 15 has been not added. Duplicate, because I have 4 elements or 4 couple of numbers. He said, okay, I duplicate 4 of them. And when he duplicate, he changed 788 by 887, 1515, 1515, 512, 125, and so on. And good, the pointer worked really fine. Everything is good. That session is finished. I hope you are now no longer afraid by pointer. I hope this teaching today is going to be helpful for you at school and make you stronger programmer. See you soon. Have a nice evening.